So guys, the first application of differentiation, obviously we've learned how to differentiate, and I just want to remind you that when we differentiate and we find dy dx or f dash of x, don't forget that it's a formula for the rate of change or the slope of that function. So it's always specific to a particular function. So the first application is how to find the equation of a tangent to a curve. A couple of things to remember here. A tangent is a line, so realistically they're asking us for the equation of a line. That's why I have the equation of a line formula written in. Couple of things we need for the equation of a line. We need a point, x1, y1. Remember, we don't put anything in for x and y because we have to have x and y in our equation of a line. But we also need the slope of that tangent. So that's where differentiation comes in, because remember, differentiation allows us to find, it's a formula for the slope at any given point. So I look at a question here. F of x is equal to 3x squared plus 4x minus 5, and I want to find the equation of the tangent to this curve at the point 1, 3. So obviously the tangent is going through the point 1, 3, which is great because I know my x1 and my y1, but I need the slope if I want to find the equation of the tangent. So I have to differentiate f of x, and I get 6x plus 4. Then I need to put in my x value, which in this case is 1. And what that gives me is that the slope of the tangent to that curve is 10. I only need the x value. Obviously they've given me the x and the y value here, which is great because I need the x and the y value for the equation of a line. But I need the slope. Now I have all three things. So I have y minus 3, and I'm getting the 3 from here, x1, y1. Then I have is equal to 10 times x minus 1. The 10 is obviously the slope, 1 is there, and I just tidy it up. Y minus 3 is equal to 10x minus 10, and I can write that whatever way I want. I can write it as y is equal to 10x minus 10 plus 3, or y is equal to 10x minus 7. And that's the answer. That's the equation of a line. Now, where they could make it slightly more complicated for you is as follows. If they give me the function, I'll give you a different function here now. We'll go 3x cubed minus 4x squared plus 5x minus 6 at x is equal to 2. So find the equation of the tangent to that curve, but this time they're only giving us the x value. Now that's okay, we'll deal with that later. So at the minute, remember, we want the equation of a tangent. So I write down the equation of a tangent, which is the equation of a line. So I'm okay. All I have is that. I have x1. x1 is 2, because I know the x value is 2. So I go about trying to find the slope when x is 2. So the slope of any tangent when x is 2. So I differentiate my function, and I get 9x squared minus 8x plus 5. I now substitute in 2, because that's specific to the point I'm looking for. 2 squared is 4, 4 times 9 is 36, 8 times 2 is 16 plus 5, 36 minus 16 is 20 plus 5 is 25. There is my m, so that's okay. But I have a problem, I need y. But don't forget that this works like any function. So if I want to find the y value when x is 2, obviously the point is on the function. So I need to find a y value when x is 2. So all I do is put 2 into my original function if I want to find the y value that corresponds to it. And when I put 2 into my original function, I get 3 times 8 minus 4 times 4 plus 10 minus 6, which is 24 minus 16 plus 10 minus 6, which works out to be 24 minus 16 is 8, 8 plus 10 is 18, 18 minus 6 is 12. There is my y value. So now I have my x1, my y1, and my m. Y minus 12 is equal to 25 times x minus 2. Just don't forget that 212 is a point on that curve, but it's also the point at which they want us to find the tangent at, because it has to be on it. So that's our first application, is finding the tangent to a curve at a point. So I'm hoping that them two examples will show you. I'll set you a bit of work on the rest of it. Okay, thank you.